You run a swarm to do code review, file a bunch of bugs. Whatever, you're generating work by spending tokens. And then you got a bunch of work and then you swarm it to fix it. And then you swarm it to review it. And then you start over again, right? And so the factory is pushing the work through. So when you start talking about software factories, it's the moment that you start thinking about work as a first-class entity.
I'll just introduce our our speakers today. So we're gonna have a fireside chat, and we've got some amazing speakers with us today. First, Drew Knox. Drew is the head of product and AI at Tessl. So he's a former Chrome and web platform PM. He's worked deep in the web standards, and he's a former research scientist at Grammarly. He's founded his own startup as well, and that was very exciting. And he is an incredible product thinker. And if you want to find anyone that can come up with insane ideas and also execute them, Drew's your man. And Steve Yegge, I don't think he needs too much of an introduction, but if you want a small snippet of the things that he's achieved, he's spent over 40 years in the engineering and tech industry. He's worked in some incredible companies like GeoWorks, Amazon, Google, and most recently at SourceGraph. He is a famous essayist. I'm sure some of you have come across some of the work that he's done. The author of the original Google Platforms rant, and many other incredible articles that have come forward, and also built some amazing and frontier level software like Gastown, and beads for your external memory and issue tracker for agents. So I'm going to introduce these two, let them tell everyone a little bit about themselves as well, and then we'll kick on with the fireside chat.
Thank you very much. Thank you, Sahil. Again, yes, secondary thank you for subbing in 5-10 minutes notice. So welcome everybody, glad to have you all here. So I'll serve as a little bit of MC/conversation partner, though I don't kid myself who everybody's here to hear from. So I'll try to leave as much time for Steve as possible to chat. We're going to go over a few things today, I think all largely around the topic of harness engineering and factory building. So eagle-eyed viewers may have noticed the slides. The title has changed just ever so slightly, a sign of how fast our industry moves. Terms have emerged in the 3 weeks from when we finalized the title to now. So we want to talk about a little bit, what is harness engineering? What are software factories? What do they look like? Give a couple examples from what we've seen just in our own building as well as from customers. And then would love to just talk about what kind of impact it's going to have on software development, on the role of being a software engineer. Where should we be afraid? Where should we be happy? All of these things. And then we'll leave a bunch of time at the end for questions. So if you have thoughts, things you'd like to ask, please be thinking of them now. Nothing is worse than asking for questions and getting silence. So please come up with questions now. Before we get started though, Steve, is there anything you'd like to say, add to your introduction or anything like that?
Thanks all for coming. Looking forward to this.
Awesome. So I'll kick us off with what is a software factory? Some of you may or may not have heard the term emerging. It's kind of becoming the new trendy, fun thing to build. So I thought maybe we could start off with probably one of the more notable first incarnations of something that looked factory-like, which would be Gastown. Love to hear, Steve, just from your perspective, what in your words is a software factory? What does it look like? What does it feel like to build one? How AI psychosis inducing is it?
Ooh. Yeah, so it's a little amorphous, right? I mean, like we're still defining these words, but I mean, kind of the way I think about it is you get into factories when you start getting into trying to be a puppeteer for agents in any sort of capacity. So if you're using the agent directly, it's not a factory, it's pair programming with agents, right? And if you're writing code that's making agents do stuff, yeah, then you've entered factory territory. That's what I think, yeah?
Yeah, I think that aligns. Whoop. I think that aligns pretty well with at Tessl. We view it similarly. Like, there's no one specific definition of a factory, right? It is largely of, are you building a system that gets humans out of the loop? And I think it tends to emerge most obviously as soon as you really start kind of cooking with agents. Like, you're a few parallel sessions, you're putting up PRs much faster than you have previously. You sort of find that anywhere a human is in the process, a bottleneck emerges, and it sort of drives you towards a world where, how can I get the end-to-end product delivery to be handled by agents?
Yeah, it's like the moment that you get AI psychosis, that's when you start thinking about software factories, right? Because that's like, they can do it. They can do it, you know, like unsupervised, right? And then you're like, well, they probably need a little supervision. And then you're like, well, I could have another agent look over their shoulder. And there you got yourself an adversarial, you know, pod, and it's already a mini factory, right? And, you know, we're fine. I mean, also, you know, like, there's a whole bunch of different surfaces where factories are showing up. And we first noticed them when we were doing development, right? And that's how Gastown came about, right? Which was, well, what if I want to run 20 agents at once, right? You know, I mean, you're not probably like interacting with 20 directly, like, and guiding them. You know, the cognitive overhead gets really hard at like 4 or 5, right? But you have a lot of tasks that can be parallelized. You need to do a refactoring or you know, any sort of a sweep, you know? And what I found, like, I don't know, was it last year? Yeah, Gastown was, gosh, time's flying. Gastown was January 1st, so I spent all last year trying to get agents to, like, you know, like run agents, right? And what I found was that you frequently need to basically do, there's a rhythm to it, all right? You run a swarm to, say, generate a bunch of reports, a bunch of issues. Okay, you run a swarm to do code review, file a bunch of bugs, right? Run a swarm to do an audit to see how, you know, whatever, convert all your to-dos, whatever. You're generating work by spending tokens. And then you got a bunch of work, and then you swarm it to fix it, and then you swarm it to review it, and then you start over again, right? And so the factory is pushing the work through. So when you start talking about software factories, it's the moment that you start thinking about work as a first-class entity, as a substance that you're manipulating, right? The work, the tickets, the design documents, the to-dos, whatever they are, right? However you're representing your work. And so I sort of backed into this, I stumbled into this when I was running a bunch of parallel agents by hand, and they were getting just lost in markdown files. And that's where beads came from, right? Which was just like, okay, what if we just like tracked the work in a graph with Git and database access and just had a way to like just store it all away and watch it go through its life cycle of its to-do work, now it's in progress work, and now it's finished work, which is like a ledger, right? Those are 3 very different like views of the work. When it's future work, it's usually very public. Anyone can claim it, you know, anyone can debate it, modify it. Once somebody claims it, it gets exploded out, like the car goes into the shop and goes up on the stilts. You know, it's all over the place. There's lots of maybe little intermediate tickets you're working on. You usually don't want people to see you working in that particular, we'll come back to that. And then at some point you actually turn it into a nice digest and you submit it, it gets reviewed, it gets accepted, and now it's your finished work, which becomes your resume. I mean, these are like and it's rights, which is like your curated view of what you've accomplished. I mean, that's the world that we're headed to. And Beads formalizes this in a way, right? I mean, it's like you can use any issue tracker you want, but I see a lot of people like defaulting to GitHub issues or to Linear or something, and those things are designed to be super heavyweight. But when we're doing software factories, I mean, did you all read Welcome to Gastown when I wrote that on January 1st? I mean, like the core idea was that it's shoveling a lot of work through, right? To where so much to where like in a software factory, you can like accidentally do the same work twice, yeah, at the same time, and get different outcomes, and then somebody has to judge which one to pick, you know? Or you can just lose work. You can do a whole bunch of work, spend the tokens, and then where to go, right? Somebody deleted it, you know, it's gone, right? So like work becomes almost like an uncountable, right? And so it's I don't know, right? I mean, like it's incredibly expensive to work that way, but Gastown was me kind of trying to figure out how to push forward. The funny thing is though, like, I mean, Gastown is like really overkill if you really want to run 60 agents, right? Recently, I haven't been using Gastown, but I've still been building my own software factories. You get into the habit of building them all the time. They're bespoke. You don't have like one factory fits all, right? Like there are some commonalities. Like I'm finding that for each project, you need to build a brain. Right? Who use Obsidian for that? It's a really good default, right? But you can use whatever. Anyone use anything else for a brain? What do you use? Gbrain? Is that a Google open source thing or?
No, it's a GitHub repo from Gary Tan that replicates Obsidian Brain, but the AI.
Gary Tan did a thing? Wow, okay, I'll check it out. I'm sure it was. No shame in that. All right, yeah, brain, and there's some other components that you put together, but I mean, largely your factory is like you shaping how the work's going to go through your agents, right? And the one, just to finish it, like the one that I'm working on right now, the one that you should all be working on right now is, okay, for the next 6 days, you want Fable to do a bunch of design work and file like implementation work that's clear enough that Opus can do it, right? For who knows how long, right? You need, right? So this is a factory shape. You're producing work to be consumed later, right? So how you choose to set that up, like, or later on, if you're going to need Fable occasionally, and maybe you'll be stuck with API access only, so you need to like basically tag your work with intelligence tiers in a way, like so you can route it and know when to use Fable, right? And so that the setup that you have on your local machine or with your team or like in your org for having these agents swapped in and out for the appropriate work, so that you can like save tokens, that's your factory, right? Whether you've like been explicit about it or not, that's what you've got.
I think there's a lot of great topics in there. Maybe I will put the one about building your own factory, everything is bespoke, to a bit later, because I think that has great touches on what is the sort of future of software engineering if we move into a world of factories. But you also, I think you outlined a few of those, the commonalities, the things where when you're building a factory, you're always going to touch on some of the same topics. And so maybe to make this concrete, within Tessl, we have been embarking on a bit of a, I think it felt at first like an overambitious goal to see what the limit was, and it's quickly become the way we're building now of moving towards a factory. So I'll walk through some of the main components, how we're building at Tessl. I will withhold doing too much of a product pitch, though. I will just say once, we've built most of it with Tessl. So if you're interested, take a look. That'll be it. So it started with 2 core goals that we wanted to get done. The first is no human written code. And the second was no interactive coding agent sessions. Sort of like just those 2 goals pretty much forces you to move into software factory territory. So the flow that we've settled on, I think it'll touch on some of the pieces you talked about. First thing is everything starts as an issue. And so I think pretty much immediately, if you're thinking about building a factory, the first question you have to ask is, how are you going to track work? How are you going to define it? How are you going to manage it? How are you going to sort of sling it around in Gastown parlance? So for us, we use linear within Tessl. Heavyweight, you are right. Sometimes we wonder if we need all of it. So what we do is we file tickets. Those tickets, we then have a background orchestrator that is polling linear basically every time a ticket is created. It will pick up anything that you delegate to the dark factory agent, which is what we've called it, built internally. And then an agent picks up that work. It creates a PR, all effectively, we started with some orchestration, like trying to automatically put up the PR for the agent. We found that frequently broke. So instead we just give the agent GitHub CLI, it puts up the PR when it's done. Then we, as an engineering team, engage at the PR level. So we review, so that brings in another one talking about code review, both from humans and from agents. It's going to be another area that you're quickly going to find is crucial.
You guys didn't say no human code review either?
Say again?
No human code review?
That's a long-term goal. Long-term goal, but takes a little bit more work than the first two pieces. We do have a general, when you review the code, before you directly leave comments and try to correct the agent immediately, you take a step back and you think about how could I have fixed the harness, fixed the overall system that the agent is acting in so that it wouldn't have made this mistake. And so we had one requirement we asked of people, before you leave any comments on the PR, at least once you have to rewind and make changes to either skills in the code base or add some unit tests, change the architecture, do something that you think could have fixed it, and try again. And then if it doesn't one-shot the second time, then you can just leave comments on the PR.
That's a really interesting observation is that no matter how you build your software factory, it basically has an ongoing hygiene and maintenance component. This was a big deal in Gastown. It's what the dogs wound up being for. They were a dedicated role. But I mean, like, it doesn't matter how you do it. You're just going to have to spend some tokens on maintaining the factory. And so if you can, if you can build it into your process so that everybody leaves it a little better than when they found it, right? So because every time you use the factory, you're going to notice that it's slightly bit rotted somewhere, right? It's just like that. It's just the natural. The skills evolve, the systems change, and the skills are effectively the new documentation, so they need updates and things like that, right? And we'll talk about how Tessl can help there, right? But it's a really interesting sort of like a mindset, right? Which is that you have to. It's like a workshop, like a mechanic's workshop, right? Or a craftsman's workshop. They got to keep it clean, and they got to spend a certain amount of time on their tools. And none of these are going to be totally turnkey. You're going to want to build the maintainer roles into your factory, I think is what I'm saying.
Yeah. And it's a great point. So I think getting started, issue tracker that can immediately delegate into an agent. It puts up a PR. You can leave feedback on the PR. Agent will address those and put up changes. That's kind of like your core unit. Every factory is going to want something that looks like that. And it might sound, I don't know, to some folks as an advanced place to start, but I actually find that agents are pretty good now. So it's not like you're going to be constantly correcting every single PR that comes up. The important piece, though, is starting to work in this way, all of your interactions with the agent become very legible. So you have the ticket, you have all of your PR comments, you have the PR, like the commits themselves. As a result, it becomes very easy to then start building these kinds of maintenance agents or sweeps, which is kind of like the next thing that usually emerges within a factory, is that no matter how good your code review is, something slips through somewhere. And this is probably true of humans as well. And so you want to set up a set of, let's call them just like outside of a diff, but just like general scan the code base once a day, once a week. You can set any sort of cadence you want. And just look for ways to improve. So ones that will typically show up that we have internally at Tessl are an architecture agent, so one that just looks for areas of code duplication or weak seams that might be hard to test. Something that looks through your test quality. So how's your coverage looking? Maybe does mutation testing or looks to see, like, are there any new areas of the code base that could be tested better? Documentation, there's, the list can kind of go on, and in fact, it probably will go on. Like, you'll just keep adding things as you find issues. And then probably the last one that I'll say, and this maybe will complete the intro to software factories, we can go into some of the other topics, are code review in general. You're going to quickly develop a whole slew of solutions there, right? You're going to have general code review that just looks for things you haven't thought to catch. Claude has a code review tool that can do this. There's CodeRabbit. You can build your own. Tessl has tools to help you set one up with a skill. And then you also want to have more targeted code review to look for the things that basically the philosophy should be, anytime you find a mistake with the agent, you should never have to correct it again. There should be something that looks for that specifically. And this, actually, I'm curious, Steve, if this resonates with you. This was like a big change for me, was how pedantic your linting can get in a software factory world. Because you're asking agents to write it. It doesn't actually matter if you're spending 50 lines of code to write a linting rule that just checks to see did they make sure that this file never imports from that file because agents frequently invert the architecture? An example of this on a side project, I was building my own agent orchestration tool, who hasn't at this point. And I had a client for working with Anthropic and a client for running the agent turn loop. And I said the harness should call Anthropic, and Anthropic should not know about the harness. And instead, the harness implemented its own Anthropic client, and then the Anthropic client imported that and exported it to the rest of the code base. So I just wrote a linting rule that said, like, the Anthropic module should never import from the harness module. It's not really the kind of thing I would have written as a linting rule in the past, but feels much more natural to do now. So I'm curious, have you seen anything like that in the past, like in the way that you verify the code that is created? Any changes from sort of like historical, like what you would have done hand coding?
Yeah, I mean, so like one thing you got to worry about is if you just put don't do this, don't do that, over and over again, then you're gonna really want a set of evals that like tell you, do you still need that when the next model drops, right? Otherwise, they're gonna accumulate forever and kind of be useless. So I think that's just another example of another sweep you're probably gonna want to set up regularly to go and basically reevaluate every single rule that you put in.
Yeah, another kind of core competency, and maybe this is a good segue into how the profession is changing. Thinking through, like, as models are released, do they solve problems that you couldn't solve before? I think I've heard you use the term like pocket evals or something, of your hard tasks that the best model can't currently do, but maybe the next one can. But there's the inverse too, right? There's maybe glue work that you've done to get the current generation of models working that is no longer needed. How are you going to tell when that happens? How are you going to strip out the context, the rules, the hooks that you had added that are no longer needed?
Yeah. So like, that's the new job, right? I mean, like, software factories ultimately are going to install 24/7 autonomous agents that are performing all of the business processes that the company's performing now, and we're going to babysit them, right? And that kind of maintenance is exactly part of the stuff that we're going to make sure gets done. And as our ambition grows and our factories grow, right, those things that we're doing by hand skills get built, they get pushed down into the infrastructure. We're looking at higher level concerns, right? And the whole thing has to be growing constantly, but it also has to be forgetting constantly, right? Like, mathematically, it's becoming really clear that forgetting is an intrinsic part of any functioning memory store. Otherwise, they get dementia and go insane, right? Or just become wrong. So yeah, you're building almost a living system.
Do you think that as we build factories, there'll ever be a stable point, like a moment where you're like, your factory is done and it just produces the work for you? Or
I mean, I think the ceiling just keeps going up for what a factory can build for you, and then above that ceiling enters engineering and craftsmanship and taste, and right? I mean, until we've built the actual literal Death Star, there will always be more work to do, Like, I just like, it's funny, the guy at Anthropic that I was talking to on Monday, who was saying that internally they feel that they are ambition bound now, right? It's just like, it's getting incredibly hard to even just think what to do, right? So yeah, I mean, the job is changing super, super fast.
Yeah.
Will it ever get stable at this point? I wouldn't bank on it.
what do you think, if you had to sketch out, like 2 years from now, a day in the life of a software engineer? What do you think what are they doing? What are the skills they should be building?
Well, hopefully they have very good work-life balance. And they come in with their coffee in the morning and they look at their team of 200 agents and go, all right, let's get started. How did everyone do? Right? I mean, it's kind of what we do right now, isn't it? We're already sort of there. So yeah, I mean, like, look, roles are collapsing, maybe ideal company sizes are shrinking a little bit, right? But I mean, like, ultimately, everybody's scared that the introduction of these software factories is going to reduce the workforce because the factories are doing a bunch of work that we were doing by hand. But there's really two kinds of companies in the world, and I think most of them are the ambitious kind. There's the kind that have one thing to do, and all they care about is making it more efficient, right? And those companies can probably shrink. But I think most companies secretly want to do a lot more than they're doing now. And they're just going to realize that once all these things are deployed and they got all that yak shaving out of the way, that they can finally like set their sights high. Yeah? And I'm personally feeling this right now just with my video game that I've been working on for 30 years. I counted up my bug backlog during COVID, and I had 100 years, okay, of work. This is from players sending in bug reports, feature requests, and me, my own things that I wanted to do. And eventually the backlog backed up to 100 years and I gave up, right? And now, you know, I have ambition to spare, right? So yeah, I mean, I just never lose sight of that, right? Because you'll get really depressed if you start thinking about, oh God, they're doing all the work now. What even value do I bring? Don't think about it that way. Think Death Star, all right? Or whatever your North Star is.
I heard a couple things in there that definitely resonate, right? Like collapsing roles. So probably folks who were more specialist, right? Like I just write really good code, or I just know how to talk to users. Going to be a little bit more general purpose. You're going to want to be able to self-serve a little bit of design, a little bit of product, probably a lot of engineering discipline. Also, you mentioned what sounded like maybe backlogs are kind of gone, right? So you're pushing a lot more parallel features, task switching, multitasking. I'm kind of curious, how do you feel? I don't know what kind of engineer you were before agents, but it does feel like I'm just going to go sit in a cave for a while and just think really hard about this one problem. Nobody's going to talk to me for 3 days, and I'm going to emerge with this beautiful, pristine piece of scalable architecture. Feels like some of that's gone away, and now it's a lot more juggle 5 features at once, sort of checking in on them as they go. Does that make you happy, make you sad, indifferent?
I mean, it's all about the dopamine, isn't it? In the end, what are you going to get it from? Right? I used to get dopamine hits from implementing Bresenham's algorithm. I'm not making this up. All right? I'd see a line draw a pixel at a time on this ancient CRT in 1991 in University of Washington, and I'd be like, yeah, I'm a programmer, right? But I didn't really want to draw a line. I wanted a video game, right? And so graphics programming has changed dramatically, right? And now we do the stuff that we really wanted to do. So, I mean, I wrote a lot of beautiful code in my game. I wrote a really nice implementation of A* search, which is a really fantastic search algorithm, especially for games. And I wrote a really lovely kernel and scheduler and property system, and I locked myself up for days at a time, and right? And that's a wonderful, kind of aspect of the job that's kind of gone now, right? But I didn't want to write A* search. I wanted monsters to chase me. Yeah, I mean, you gotta remember what you're in it for, right? And you're in it for outcomes. You're in it for experiences. You're in it for delivery. And ultimately, that kind of fun that we were having along the way was, temporary. I still get some of the buzz from coding just by making the AIs go rewrite it, to be better, and then I look at the output and I'm like, yeah, you get them vibes a little bit, right? But it's a new world, right? I mean, I liken it to a dog sticking their head out the window. You get the smells way faster, right? It's nice. It's also nice to have one smell and kind of like a right? But I don't know. It's just we're headed towards a faster world.
I've definitely noticed to that dopamine hit, a lot of times, some I get just from crafting the system. I'm sure there's lots of folks in here who love I've built my beautiful little world that this agent talks to that agent, and then this check runs, and all of that is everybody wants to build their own workflow engine. At least at Tessl we do. We love workflow engines.
There were 50 of them at Google when I left. I was keeping an inventory of workflow engines that engineers had built at go/RGB for Rube Goldberg machines. Yeah.
Yeah, it's like
Engineers love
catnip
to
for
build
us.
them.
Yeah. You also get to spend a lot of time thinking about architecture, technical design. Like, in some sense, some of the more, I don't know, what people might have called like the elevated parts of the job, the senior architect, the visionary aspects. Kind of everybody gets to work on those now, right? Like the drudgery of writing code, I'll call it drudgery to big up the architecture. I know some people really enjoy just the actual crafting of good code, but it allows all of us to move up a level, probably to things that we aspired to. And maybe to your point, keeping a focus on that, on where you had wanted to go in your career, probably was moving to some of the things that now we get to work on more with the coding agents. I'm curious though, do you think there are any risks, any things that we should be particularly vigilant as we move into this world of factory building and more agentic review of code, less human review of code, like anything we should hold on to?
Yeah, I don't know. We gotta learn the lessons by doing it, right? So go burn tokens. The big lesson I think we all learned from January through April, you could argue that Gastown kicked it off in a way, was token maxing, right? And the industry just went through a love affair with token maxing that was a lesson that we had to learn, which is that first you have to teach people to spend tokens. Like their token spend will go through some step functions. But then once they actually know how, they become pigs, and you have to teach them to not spend tokens, right? It becomes like the new challenge. So if you enable Copilot for your whole org, you run the risk of blowing your AI budget for the year by 2 months later, right? 2 weeks later. So we've noticed, actually Drew and I independently came to this conclusion, is that there's a training problem ahead, right? There's an enablement problem.
Yeah.
Like orgs, people don't know how to do agentic coding, let alone build software factories, right? But I would argue that every knowledge worker in the next 12 months has to level up to at least the baseline level of AI literacy, of being able to use an agent to help them with their work, right? And that's it's not that bad. It only takes 5 hours, according to Netflix, of good training for the light bulb to go on. Until then, they're all terrified that AI is going to take their job. And after that, they're excited to have the conversation about how they and their agent can help, right? So this is what we run into, is we talk about software factories to companies who haven't even started using agents yet, right? And we're talking past them. So there's a huge, I don't know if we call it a risk, but the risk is that we don't train people, and all of a sudden there's a big train wreck, right? Companies don't operate properly anymore.
Yeah. I think with factories in particular, to your point, it can often be presented as this frontier, this thing for the people who are like some greenfield startup that's just getting started, working 996, totally AGI-pilled. But really, at the end of the day, it's just a matter of finding repeated workflows and automating them. Right? Like it can be a very just piece-by-piece task. It doesn't have to be scary. It doesn't have to require a lot of advanced capabilities as you go. It's just a dedication to working in a particular way, taking a step back, and automating things. I think that's a lot of the training you want to do, right? You want to show people how to view the problems that they're working on, get them to at least a couple points of success. I think with token maxing, obviously it's become a bit of a meme now as everybody saw the bills that sort of came due at the end of it. Of course, I'm sure there was a way we could have gotten a lot of these success stories without quite so many zeros on the end of the bill, but there is a certain amount of, you kind of have to just let it rip first, find some things that work and get people excited, and then rein it back in, right? If you try to start from the beginning of being prudent, you'll sort of undershoot the mark every time.
Yeah, let it rip. And with that, maybe we should do questions.
Yeah, let's do some questions.
All right, let them rip.
So we don't have microphones for folks, so just shout them out, raise a hand, I'll call on you, and then I'll repeat the question for everybody, and we can go through. So question for everybody, what's our favorite recent factory technique or something that you've tried that was really impactful or cool? You want to take it first, Steve? Or you want me?
Yes, Fable lashing together a sled dog team of opuses. That's going to be the new one, right?
Fable,
but I mean, for real, the technique of getting smarter models to manage lower tier models, that's going to be a game changer if you can dial that in, right? Because
I think probably maybe a very specific one for me. So I have developed a sort of recurring harness that for every new project that I work on, I'll put together. A big part of it, a sweep to use your parlance, is on test quality. And I've added in mutation testing as a very particular. So if folks aren't familiar, mutation testing is where you go in and you permute the code in ways that should be breaking. So you like change boundary conditions on conditionals, or you will change sort of magic numbers within the code. And then you look to see if any of your test suite caught what should have been a breaking change. You can do this in two ways. You can do it on a diff, and it'll only make changes within effectively the PR you've put up, or you can do it across the whole code base. And I swear by this now. So I have it set up where every PR I put up...
So like it finds a bunch of stuff that coverage doesn't?
Exactly, yeah. So the combination, you'll set like a minimum bar on coverage. Typically what I'll also do is set in PR, like in CI/CD, the PR that went up needs to have, like within the diff itself, near 100% coverage. So it's like you don't want to have a file that already has a lot of coverage, a change within that sort of sneaks past. But coverage can often be theater, so you want a way to actually prove that the tests are catching real behavior. So on every PR, I'll have mutation testing set up, where you don't want it to run directly because there can be false positives, but I'll have an agent look at the results of a mutation testing report on the PR. We'll leave comments for anything that wasn't caught, and it pretty much always leads to an improvement in the test suite. And then once a week, I'll do the same thing over the whole code base. And with that, I find my test suite is pretty reliable and allows me to sort of get much closer to not reviewing the code.
What's like an example of coverage gap that it found where you're like, oh, I'm very glad about that?
Probably the biggest one is in boundary conditions. So there'll be a lot of, there is business logic encoded in things like this list will never be empty. And your agents love to test things like once or twice, right? So they'll do 5 and then 50, and they'll never check 0. And so that's probably the biggest area I see it catching over and over again, is the little assumptions that you have baked into your product that need to be represented in the code. You want them to be in your test suite as well. So the question was, how much of the factories that we build are deterministic versus just relying on the model to do the right thing? I call it the trust fall version of the factory. Within Tessl, we started very deterministic. So we tried to have clear phases where the agent would build something, and then we had our harness come in and create the PR and put it up. We would, as comments were made, we would ferry them back down to the agent. At least for us, we found pretty much you want to rip that out. Like every piece of deterministic code you write that tries to orchestrate, it becomes a source of brittleness in the factory. And again, I'm saying this is from our perspective, right? So what we found, it becomes brittle. So it's pretty shocking the number of times you think this is the truth for every single feature we build, and then you realize, oh, actually like 15% of the features don't follow this pattern. One simple one is like stacking PRs, and then you realize like, oh crap, our orchestrator has made that physically impossible at this point. So we've pulled back pretty aggressively to say, you give the agent the GitHub CLI, you tell it what to do. The main place we put deterministic checks are at the end. So we have a bunch of hooks, we have a bunch of like CI/CD, like run the unit test suite, check to make sure certain skills were loaded before you can stop, things of that nature. Yeah, so the question was, do we just operate with the hooks of the basic harness? And I would say, yeah, like most of it is, we will, I'll use as an example for myself, anytime the agent tries to do a tool call to do a git push or a git commit, run the unit tests and linter, and if they don't pass, block the tool call and tell it, you need to run these first and go fix them. If it tries to stop session, you check, is all your work committed? Did you put up a PR? If not, you can't stop, you need to go do that. But otherwise, my preference, and at Tessl, we're certainly a lot more just lean on the agent. I'm curious about you.
Oh, excuse me. I think there's a lot of different ways you can kind of like, there's a couple different ways you can like think about determinism, but one axis is, OpenClaw versus Gastown. OpenClaw is give the agents a goal and let them go swarm off and do it. And Gastown is break your work down into really small deterministic pieces that they're going to execute in a specific order, right? If the order matters, otherwise they can do it in whatever order, right? But the idea is very different from OpenClaw, right? So that's one way to look at it, right? Which is how much leeway do you give the agents versus how much are you trying to like lay out what they're going to do, right? There's another dimension to it, which is quality, where you're trying to, and it sounded to me like you were focusing on the quality dimension, which is how do I make these things not make a mistake in one pass? If you're talking about LangChain, you're talking about trying to keep things on the rails, trying to make them not skip one step, and you're thinking about it fundamentally in terms of how can I make it smarter in one pass? And the answer is you wait for the next model drop. I spent all of last year trying to code this. I have a repo up on GitHub called Vibe Coder, or maybe VC, I have 2 of them, where I tried to solve this problem. And I realized that the answer, you're just fighting the bitter lesson. The answer is you do multiple passes, and the answer is always swarming. Swarm, 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 adversarial reviews, consensus, just like painting these walls here. Don't think about how can I build a machine that will paint the wall perfectly on the first coat every time. No, multiple passes, multiple coats, right? That's how we code. So factories have to be very stochastic, and quality becomes a dial that you choose how many tokens you're going to spend on it. Does that make sense? Cool.
I think determinism of the shape of work is a good one too, though. Like breaking things down into task trees.
I like that for
Yeah.
SOC 2 compliance.
Yeah, exactly. Why don't we go here? Yeah. So the question was sort of philosophy to factory building. Do you start from a top-down, and I will reinterpret a bit, tell me if I've gone too far off the rails. Top-down, sort of start from a vision of how the system should work, from a central orchestrator that sort of builds outwards, or are you more bottoms up? Like just start with a unit of work and then layer more on as you find what works? Steve, what do you think?
Yeah, so I mean, I'm always reworking mine, right? Like Gastown was like a perpetual rework until I got into a specific shape that I particularly like, which is on the one side, I have a handful of agents that I do deep design reviews with, deep context. It's like I call them a crew. And on the other side, there's the throwaway, ephemeral, really well-specified work that we're just going to throw agents at, right? And that shape keeps recurring in my work because the throwaway stuff is like, oh, I just have a big parallelizable thing. I'm just going to split a fleet up, right? So I keep making my way back to the Gastown shape, but I started from first principles again recently, and I was building a software factory, and it's interesting because you build it up by adding agents and maybe letting them know about each other, and they share work, and it gets to a certain point, and they're humming, and you'll have 12 agents running, and you realize my factory is the wrong shape. I finally, you know what I mean? It's a stochastic process also, it's discovering what your factory looks like. So you're like, God damn it, I got to shut the whole thing down now and stop all the agents, let them drain, right? And then move all the directories around and reshape the factory scripts and stuff so that they all know where their new places are, create any new clones or agents that I need, and then boot that thing back up again and see how I like it, right? And it takes a few iterations, right? And it seems, I haven't figured out yet which parts are bespoke to the project and which parts are, generic that I'm going to bring along with me. But boy, the faster you can kind of set up and tear down your factory, the better you're going to find your way to it.
Yeah, I think it's quite similar at Tessl, and I'll do a light pitch here for the Tessl agent, which tries to help you in building your software factory. We take a very bottoms-up, iterative approach. I think for 2 big reasons, well, maybe 3. The first is everything is changing so fast. It's really hard to just start from the top and get it all right as you go, and it's much easier to say, here is a unit of work that I shape it around the work itself. This is a task I know I do every week. I just want to automate it. and then you sort of layer on piece by piece, you'll then have 4 or 5 automations that look kind of the same shape, and so you'll build a thing that makes it easier to make that kind of automation, and you sort of, like a reverse jawbreaker, like you build up many layers on top of it. It's also the best way to actually get unstuck and start working. I think anytime you try to ingest the entire software development lifecycle in your head at once and say like, yes, I will design everything perfectly. It's like a recipe for spending 2 months figuring out something that won't even work at the end. But again, if you just say, I do this every week, what if I didn't have to do it? What if an agent did it? You know, like what if agents just bumped our versions every week? Or what if agents ran mutation testing and then made our tests a little bit better or a little bit less flaky? We found that works a fair bit better, and so that's the philosophy that our product takes, is just find one thing each week and make it a little bit better. So the question was, how do you train people on AI native agentic development, but in a way that it stays relevant, doesn't grow out of date with the next model release or the next new technique or new tool? I know you just had a post about this, Steve. Maybe you want to take it.
I did, yeah. Not to toot my own horn, honk, but actually Netflix solved this problem for us. Thank you, Netflix. So I just posted about this. It's called the Flat Curve Society. It's a Medium post I just did where I talk about a program that Netflix presented that shows that there's an exact formula for getting people over this hump, and it takes 5 hours. But it has to be their manager and their work on working hours, blessed, with a trainer. They were training our book as the curriculum, although you could train anything, right? They just have to be doing the real work. And it's that immersion. It's not really training. It's more like instructor-led work, real work. The whole cohort, if it's no more than 10 people, you can read all about it, but basically they will all flip into the 4 million tokens a day category, which is single agent synchronous throughout the workday. And that is actually the moment where they have become AI literate and they can start having real conversations with you.
Yeah. I think probably the most important thing is to get people to some kind of an aha moment. Because for a lot of folks, it's not really that they need to be trained on AI. They need to get excited enough that they go start training themselves on AI. Like a lot of people are just afraid, or they don't think it works, or they're just put off by the hype of it all. And so I think a lot of that Netflix training course was like, give people a day blessed with their team, with their manager, and just get them to a place where they are now excited to use agents. And then a lot of stuff will come for free from that, right? Like they'll just go do side projects, they'll try things, they'll test out.
They know now how to, they can now delete your database accidentally.
Yeah.
You know.
Exactly. That's what I thought. Like I basically, I feel like I do those trainings. I work at Google, so you know the culture. And I'm doing those trainings. I feel like I'm giving some people a hammer, and some people are using it in ways hammers shouldn't be used.
Yeah.
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 I mean, so getting them to literacy and then multi-agent literacy is like 2 steps of a 10-step journey, right?
So the question was any common components that keep showing up, even if the factory itself is bespoke, there's sort of like stock units that you use within it.
That's kind of your whole product, isn't it?
Hopefully, yeah.
Did you pay him? Is that a show?
Yeah. You can. Well, I'll PayPal you afterwards. No, certainly at Tessl we think that there are some, and we try to help with that. So maybe I'll start with the ones that we've been building. You want some way to connect your issue tracker to your source control, right? So we have a Tessl app for linear and for GitHub. Very basic. All they do is you can delegate work to the linear app, and it will forward it to the GitHub app so that you can kick off CI jobs that run workflows. You need that. We didn't have that at first, and we found, and this is surprisingly common, Maria, shout out to Maria, built our first orchestrator. And so there was a period where for like 2 weeks, every PR and every comment was from Maria. And there's just like identity issues there. There's like nice UX pieces. So how do you hook that up? That's one thing that you're always going to want to build. Another is some kind of a cloud environment for running agents. So you can do it in GitHub Actions. It's not the cheapest if you run a lot of automations through GitHub Actions, and they're not the most suited for long-running agentic tasks. So you have to like set up sidecars that refresh your GitHub tokens, and it's not the best. So
Is this like a hosted service like that somebody needs to build?
There are, I think, some folks, they tend to tie it to a broader like orchestration platform, but there are tons. There's Factory, there's Warp, there's Oz, there's like lots of folks who try to help here, so there are ones you can pull off. Tessl has one that's very simple. It's just you use a skill to define a workflow, and then we'll just run that in a cloud sandbox with access to GitHub, and it can go as long as you want. And then probably the biggest one outside of those is a set of code review tools. And so you want ways to do agentic code review. You want to know, as I leave comments, in addition to the agent's comments, are those getting worked into the code review so that next time the agent will catch it? You're going to want ways to do more specific checks. So at Tessl, we have a thing called verifiers, which you can think of as very, very focused linting rules that are powered by LLMs. So it allows you to do slightly more broad, vague things, but still targeted to a specific file and a very focused check, like every JSX element must have ARIA attributes on it, right? And you can check those kind of things. The follow-up question was plumbing between, I'm guessing, like workflow steps or things like that. I would say for us, we found that those get in the way sooner than they outgrow their welcome very quickly. And so we have moved to a world where most tasks are just a single agent runs to completion, and then you have a bunch of checks in CI that improve its quality. And besides that, you're just running the GitHub CLI for it to interact. Probably the main orchestration we run is in the task tracker itself. So you'll create a parent task with things that it blocks and then unblocks, and that's effectively your DAG for execution. But at this point, we've built like 6 different orchestrators in Tessl, and every one starts with a lot of plumbing and ends with no plumbing, because we always realized it was more hassle than it was worth. So the question was, any unique challenges if you want to use local models instead of the API frontier providers for building a software factory? Steve, anything you want to jump with?
I think there's a huge market opportunity here for somebody to come along with like hosted local models with a Claude Code like hosted turnkey offering. You know what I mean? I mean, just a drop-in replacement for Claude Code that uses local models on cheap inference, right? Or even ideally finds a way to use whatever GPUs you have around, right? I mean, I think that like people want off the Claude Code train if they can find local models, especially if we can fix that intelligence arbitrage problem, right? Because then you get one Claude Max account to do all the planning, and you have the open source models do the implementation. I think we're 7 months away? I mean, by December, I think we should all have something there. I can't imagine we'll all still be paying Anthropic for all of our tokens by next year.
Yeah, I think probably the 2 big things I'd add to that. For a while, folks have said like open source models haven't had their Sonnet 4.5 moment yet, where it's like agents really got good. I think some people think maybe GLM 5.2 might be that. Problem is, that's still going to have to be hosted, right? Like GLM 5.2 is, I think, over 1 trillion parameters or something.
Yeah, have you seen the rig you need?
Yeah. You need like a
20 in that range or
40K.
something?
Yeah, exactly. So probably the biggest thing you're going to face is just for the foreseeable future, if you want truly local, like I'm not renting anything, this is just sucking power from my outlet, you're going to be limited to like much smaller models. And that's going to be tough as the distillation curve sort of brings knowledge down. But I think coming back to something you said, Steve, you can just throw more tokens at it. If anything, you can be like even more gluttonous with tokens because it's just power. And so maybe connecting it back, maybe you do need more orchestration then, where you need to run a task through like 6, 7, 8 review passes before you move on. You can basically make up a lot of that intelligence. So you might have more wiring that you have to do that.
This is why factories are so important. It's because low-tier models are always going to be important because they're cheap and they can get stuff done, but they need help being kept on the rails because they're low tier, right? So the factories they fill that space perfectly. I think as the higher tier models come along, you're going to use them to just like keep your factories on the rails, but you're always going to use the lowest tier models you can, right?
Yeah, the factory mindset, I think, brings you into one of process optimization and monitoring, right? Like, you could use, I don't know, I'm going to reveal a lack of physical knowledge about like real factories here, but you could use the most titanium, platinum coated screws for every single thing, and you'd be like, okay, but I replace this piece of machinery every 2 months, so why would I spend all the money on it? I think we're gonna have the same thing with models, right? Where maybe you use Fable to plan, you use Opus to break down into milestones, and then
DeepSeek implements it.
yeah, exactly. And I think getting good at that is going to become a core competency of software engineering as you look at not a given PR, but a system that produces PRs. How do I do that effectively? So how often are we changing models versus using the same? Maybe specifically for code review, but also just more generally.
I'm making a push in that direction just because I don't really like telling my wife I have 5 Cloud Max accounts. She's like, what is this? So, yeah, right? I think, because they're much better at reviewing than generating. So you can generally go with like a whole class lower and still get a pretty good review, right?
I think similar. For me, anytime, and I think Sahil, Amy, keep me honest on this as well. I think if you get into the game of trying to pick a specific model for your interactive sessions, it's kind of a losing game because it's hard to anticipate when a task is going to get complicated, when a mistake will be found. And so I find most people who go that route, they always end up doing the biggest, fastest model or like best model they can afford all the time. I think where it pans out a bit better is in the factory mindset, if you can find a recurring task and sort of draw a box around it and pull it out and say, here's a workflow that I do a lot, or here's a playbook for adding a feature to the CLI or shipping a front-end change, et cetera. Once you have that, now it's very fixed. Like you know the task is going to go through, you know how often it's going to fail. That becomes a much better target for optimizing the right model. And because it's something you put a box on, you're running all the time, it's worth it, right? So code review is a great example there where code review is pretty stable, right? You can maybe have a few gates by complexity, size of the diff, and then it is actually consistent enough that you can set a model for each type that you want to run. Same with any automations that you create. And so that, at least for me, is where I found more success. And then Opus or Fable for any interactive session is that's my default, at least.
All right, well, thank you, everybody. This was lovely. Cheers.